Alright, so last time I left you with a cliffhanger, which was why do we only see Maria on the side of the moon facing us? We didn't know that there was no there were no large Maria on the other side of the moon until that fateful day when the first Apollo astronauts flew around the other side and we're like, oh hey. Actually, there are probably some probes that we sent before to map the other side, but you know, the first like real human eye to see the other side of the moon would have been one of the Apollo astronauts. And anyway, so what's the big mystery? Why would the Maria only be on this side of the moon? Is there something to do with the Earth? Yes, it's called gravity. Now we're going to talk about um, let's see here. In the orbital properties, actually the rotation properties, we're going to talk about that how the moon is in a synchronous orbit, and we can only see one side of the moon always. That's because the moon rotates and orbits around the Earth at the same rate. The reason why that happens is because of tidal forces. Basically gravity is locking the moon in. It's slowed the rotation of the moon down little by little until finally it just stopped. And by the way, the moon is doing that to the Earth as well. I think I'm going to talk about that. Well, I'll wait to talk about that. But basically, through theoretically through some mechanism, the way the Earth gravitationally pulled on the moon, it would have probably made the crust thinner on the side facing us. Basically, the gravity of the Earth will kind of stretch the moon out like an egg, but it's not as exaggerated as an egg. And uh, as this would have happened also when the moon was molten and more liquidy and less solid and more easily stretched out. And so as the heavier materials were falling towards the center of the moon, just that's the way gravity works. Gravity pulls heavier, more dense materials more strongly to the center. Um, it's thought that that might have made the crust on this side, the side facing us, thinner. And a thinner crust means that it's easier for lava or magma to get to the surface and form these big plains of lava. So whether it was through volcanic activity or big meteor impacts, it's thought that the thinner crust facing the Earth allowed for these big Maria plains to form. It's pretty cool that the Earth has such a big influence on the moon like that. And the last surface property I'm going to talk about, although there's plenty more to talk about, but this is kind of one of the major ones that I want to touch on. It's the regolith. Regolith is a very fine lunar dust, very, very, even more fine than sand. It's like dusty, but it's also because there's no weather erosion or other types of erosion besides meteorite impacts. Because there's none of that extra type of erosion, this lunar dust is actually pretty dangerous. It's very jagged and sharp and dangerous to breathe. It would damage the lungs pretty badly. But it comes from basically meteoroid impacts. Over the billions of years of impacts, each collision would have broken the rocks up into smaller and smaller pieces until they finally become a nice fine ground up dust, basically. And you see that on beaches too, right? Because sand just didn't come from nowhere. It was basically used to be rocks, and as the waves, over the years crash and crash and crash repeatedly over the shore, they move rocks around, the rocks bang into each other and break off little pieces, and over a long period of time, the rocks get smaller and smaller, and you get sand. If you ever looked at sand under the microscope, you know that it looks like tiny rocks. So anyway, and so the gravitational pull, as I just talked about, does have a big impact on the moon's rotation. and of course our orbital properties. The moon is in a synchronous orbit around the Earth, and this is due to tidal forces. We experience tides in the Earth, as I talked about before. The gravitational pull of the moon kind of nudges up the oceans a little bit. But the Earth exerts an even stronger gravitational effect on the moon because the Earth is larger. Well, I mean, that I don't want to get to. That's a little confusing because there's a whole Newton's law thing going on, Newton's third law thing. But anyway, um, the Earth does have quite a big impact on the moon, especially in terms of because the moon is smaller, it's easier to push around, and so it's easier to slow down its rotation rate. And that's what happened. You know, the moon, I'm sure, was rotating at one point, and I mean, it still is. It's still rotating, but it's rotating at the exact same rate that it's orbiting. So it spins around once in 29.5 days, which is the same amount of time it takes to go around the Earth. So, yeah, and actually the Earth's orbit is slowing down too, but since the Earth is bigger and it's a little harder to push around, the moon hasn't been as successful at slowing us down to the point where the Earth spins around once every 29.5 days. Um, it's thought that in roughly 100 or so, well, I don't know, I mean, in hundreds of billions of years, the Earth would slow down enough to become involved in a synchronous orbit. Thing is, the sun's going to die way before that, so it'll never happen in the Earth's lifetime anyway. And like I said, the orbital period of the moon is 29.5 days, which is about a month. No coincidence that a month is based on the moon, the lunar calendar. And because of the fact that the moon orbits around the Earth and that the sun is always kind of in one direction at certain points of the year, then we see different phases of the moon. We see the light hitting the moon in different angles. And I want to show you that through eyes in the solar system. So let me bring that over. So here's eyes in the solar system. Real quick though, because this is kind of exciting. Let's see here. So two probes have been launched recently within the last month, and one of them is MAVEN, which is a NASA probe launched on November 18th, just what, a little over a week ago. And actually, I didn't want to zoom in on MAVEN. Let's find the Earth here. Earth, where are you? Holy cow. Yeah. There we go. Let's go on to the Earth. Alright, that's what I wanted. So, yeah, November 18th, MAVEN was launched. And November 5th, Mars Orbiter mission, was launched by the Indian Space Research Organization. Wait a second, you're saying, what? This is launched earlier, at the beginning of November, and it's only this far out? Well, take a look. Let's go back to November 4th and put the speed up a bit. Watch what happens to the Mars orbiter mission. Actually, I should have. Let me go back in time again. Okay. Whoa, what's going on here? Mars orbiter mission. It's going around the Earth like crazy. Of course, it's 15 hours every second. And the orbit keeps getting bigger and bigger. What's going on is the rocket that launched this wasn't powerful enough to just launch it and escape the Earth immediately. And so this is how they decided to build up speed to reach Mars's orbit. Whereas you just saw MAVEN launch right there on the 18th, and it is heading straight. It didn't need to pick up any speed from here, and Mars orbiter mission is still orbiting, building up speed. Pretty soon, though, it's going to head off. We're about, this is today, and actually today Mars orbiter mission started heading out to Mars. So if we zoom out, get Mars here, Mars is going to, it's going to take about a year, I think, or so to reach there. Let's fast forward a little bit, and Mars is going to come, it's going that way, and they're going to meet. Whoa, getting close. This is July 7th, 2014. Zoom in a little bit to Mars. There they are. September 11th. Oh, interesting data stop. Um, September 14th. So Maven is going to reach Mars first. And watch what Maven does. Mars is gonna capture it. Wham, wham, bam. See it going around there? And it's eventually going to settle in on this orbit, which is going a little fast to see. Let me slow down a little bit. So yeah, it's going to orbit pretty close to Mars. Whereas the Mars orbiter mission, as you can see, is going to have a pretty wide orbit. And if I speed things up, you can see the consistent orbit. So that's what Mars orbiter mission is going to be doing. And you can see Maven is this little bright orbital circle here. So they're going to be in a stable orbit and explore Mars. Anyway, I didn't want to take that long to show that, but I thought that was pretty cool. And that's just happened within the past few weeks. So let's go back to Earth. Where's Earth? There it is. No, didn't want to do that. Okay, so here's Earth. Alright, so let's talk about the phases of the moon. First off, let's find the sun. Let's orient it the right way. Nope. So North Pole's up here. There's the sun. And where's the moon? The moon is right there. And if we speed time up, we can see which way the moon is going. So the moon is moving towards the sun right now. And as you can also see, the moon is going to go above the sun. It's going to go up here, not in front of the sun. Sometimes the moon is up here, sometimes the moon is down here. Once in a while, though, it goes right in front of the sun, and that's when we see an eclipse, which is kind of cool. But in this case, you can see in this orbital path anyway, in a couple days, the moon is going to go above the sun. And so what does the moon look like at that point? Well, if you look down here, make sure this is still in here. There we go. The sun would be over here, light's shining this way, and which is what we're seeing. So we're standing on the Earth here, looking that way, and the moon is between us and the sun, which is what you see right here. So we're seeing the dark side of the moon. The lit up side of the moon is facing away from us. So if we zoom into the moon, we can also see that. So we see the dark side of the moon. We have to orbit around to see the light side. And there's the Earth behind us there. Let's go back to Earth. And there we go. There's the moon again. So as time goes on, we're going to see the moon is going to continue in its orbit. Now it looks like it's just going that way, but if we look at the Earth from above, we go high enough, we can see the orbit here. The moon was right here because the sun is, again, that way. the moon was here, and now it's going around in an orbit like this. So you can see the moon's actually going around like that. So it's going around once. And let's just talk about the phases. So right now, being behind us, we're at full moon because the sunlight's coming this way past the Earth, lighting this side of the moon, and we see the moon, the lit side of the moon. So again, the sun is here. It's not quite full moon yet, but the sun is here. Light comes this way, past the Earth, hits the moon, and we see. So there's the Earth over here. What do we see from Earth? We see full moon, the lit up side. And you can probably imagine how it works as the moon keeps going around. We see either more and more of the lit side or less and less of the lit side. Just to give you an example, let's try to find a crescent. So a crescent would happen Earth. Let's find the sun. The sun's here. Okay. So we want the moon to be like in this area for crescent. So let's fast forward. Actually, we want to be centered on the Earth. Gotta make sure the sun's still in the front. Yep. Okay. Fast forward. Whoa! Too much. What? Jeez. Ah! Okay, let's try this again. Gentle, gentle. Alright, so the moon's like, no, sun's gone. There's the sun. Gotta do it again. Yep. So the moon actually needs to be here-ish. So let's gentle, 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 gentle. Okay, okay. What? Where'd you go? Easy, easy. Okay. That's pretty good, right? Is the sun still... Alright. So we got the sun, the earth, and the moon is kind of at an angle and closer to the sun. So if we look at the moon from the earth, let's zoom in. It's actually we're only gonna see a little crescent. The crescent that you see on the earth from this point of view should be mimicked on the moon, just based on, if you're in a spaceship looking at the earth, we're looking at the moon from the same angle as the sun, so you should see a similar crescent. It's kind of hard to tell. The crescent looks like it goes about, here's the border, light to dark, so it's maybe this much is crescent, maybe similar to this. Again, here's the boundary between light and dark. So anyway, I would suggest, if you can, to load eyes on the solar system on your computer and take a look at it. Pretty cool program. Try to look at the different phases of the moon on there if you have some time. Can't do it on the school computers though, so you want to do it at home. And we're at 18 minutes, so I'm going to stop there and continue on with the interior properties in the next video. Alright, talk to you later.